Hello friend, in this video we have question and answer. The question will cover torsion, single shear and double shear. It says most shafts undergo torsion during their operations in machines. Outline 4 assumptions used in deriving the simple torsion equation. B. Rivets are commonly used as joining elements. With the aid of sketches, describe the difference between single shear and double shear joints. A tensile load P of 60 kilonewtons is applied to a member as shown in the figure below and is carried at the joint by a single rivet. The angle of the joint is 60 degrees to the axis of the load. Calculate the tensile and shear stresses in a 30 millimeter diameter rivet. Now this is the member that has a joint which is a riveted one, and the load is applied here and it is tensile. Now they are saying the joint makes an angle of 60 degrees with the axis of load P. Let us look at the solution of these problems. The following are the assumptions that are taken in deriving simple torsion. Okay, one is that the material is homogeneous. In other words, it is of uniform elastic properties. Next is that the material is elastic and is following Hooke's law with shear stress proportional to shear strain. Number 3 says that the stress does not exceed the elastic limit or limit of proportionality. Another assumption which we can take is that circular sections remain circular after the application of the load. Another assumption taken is cross sections remain plane. Of course, this is certainly not the case with torsion of non-circular sections. Assumption number 6 that is always taken also is that cross sections rotate as if they are rigid. In other words, every diameter rotates through the same angle. So now part B says we differentiate between double shear and single shear. Let us consider a simple riveted lap joint below subjected to tensile force F, which gives rise to a tangential shear force. If the area of cross-section of the rivet is A, then the average shear stress is tau average equal to force out of area A. Remember, this force F gives rise to a tangential shear force P. Therefore, tau average is going to be P out of area because P is equal to F. So when you look at this kind of simple riveted joint, if I apply a force F and another force here, I'm trying to shear out this joint, and therefore it is realized that during or after failure, this pin is going to break into 2 pieces. So when you look at it carefully, you'll find that there is this force F resulting into a shear along this single area A. So that's why the average shear stress is equal to P out of A, and this joint is said to be in a single shear. Let us look at double shear. If we consider a butt joint with 2 cover plates and the assembly subjected to tensile force F with A as the area of cross-section of the rivet, this pin results into shear force P, which is equal to average of F. So P is equal to F out of 2. When you look at this scenario, you will find that the average shear stress is given by F out of 2A. When you look at this is a force applied on a joint with 2 cover plates. I just took the one side of this joint because this should have been 2, where you have one member joined to another one with 2 cover plates with maybe 2 pins. but I've only just showed one for purposes of this particular example. So if I apply a shear force, if I apply tensile forces at the end of this joint, then these shear forces on one pin here, it is going to divide into two forces, F out of 2, F out of 2, and these are the forces which are responsible for shearing out this pin. When you look at this pin in a double shear, it will shear out into 3 pieces. Therefore, if I look at this, maybe I have a force F, then it will result into these shear forces F out of 2, F out of, meaning that my tau average, which is the average shear stress, it will be F out of 2 divided by A, and this is going to equal to F out of 2A, and this scenario is said to be double shear. Now part C is telling us that we have a tensile force P equal to 60 kilonewton. If the joint is at an angle of 60 degrees to the axis of the application of P, then it means this P is going to have different components. It will have a component that results into shear force that is going to act along here, then also a tensile force that is going to act just along the axis of the pin or the rivet. Therefore, to get the force responsible for tensile force or for causing tensile stress, it is going to be tensile force Ft, and it is going to be P cos theta. I just resolve this force along this line that is showing tensile force. Therefore, Ft will be 60 exponent 3 times cos 30, and this is going to be 51.96 kilonewtons. We know that tensile stress is equal to force out of area. How about the area? The area is pi d squared out of 4. Diameter is 30 millimeters. So to convert it to meters, we multiply by 10 to the power negative 3, or we just divide, we get 30 divided by 1000, we square. So when we substitute in the values, we shall find that area is equal to pi times 900 times 10 to the power negative 6 square meters. If I bring it under the force, it will be tensile stress sigma equal to 51.96 exponent 3 times 4 divided by pi 900 times 10 to the power negative 6. This is just force out of area, and the tensile stress sigma T is equaling to 73.5 meganewton per square meter. Now let us look at shear stress. The shear stress is equal to shear force out of area. Now area, we know it already, but let us look for the shear force. The shear force is obtained by resolving P with the angle of 60. So we are resolving it along where the joint is lying, because that's where the shearing is going to take place. So Fs, which is the shear force, is equal to 60 kilonewtons cos 60, and this is going to be 30 times 10 to the power 3 newtons. Now it means tau, which is the shear stress, is equal to that force divided by area, and this will be 30 times 10 to the power 3 over area, and finally the answer is 42.44 meganewton per square meter. Thank you so much for watching. See you next time.